mean, it depends on which one you're looking for. So like for that one, like the unknown is the across from F. So that would be your A. Okay. All right, so we're going to skip the rewind because we just did that stuff. So again, law of sines and law of cosines are to find missing measures when you have certain information and they aren't necessarily right triangles. So previously we've used trig ratios with all right triangles. Here they don't have to be right triangles. It's just special relationships between between the sines and the sides and the cosines and the sides. So remember, law of sines is just a ratio. Law of cosines is the longer equation. It's always going to be sine for the ratio ones. It's always going to be cosine for the long equations. Okay, so the last thing we're going to talk about from chapter 8 is vectors, which seems like it's a little bit random, but it goes here because you have to know about trig ratios to understand vectors or to do the direction of vectors. So it's kind of seems like a little bit of a tangent, but the reason that it's in this section is because we need to use trig ratios. So a vector is a quantity that measures speed and direction. So in other words, it represents a speed and direction that an object moves. So essentially, vector AB right here is something moving, some object moving from A to B, where A is called our initial point. Why do you think that's called the initial point? That's where it starts. And then B is the terminal point because that's where it ends. Okay, so yeah, it is, yes, very obvious. Initial where it starts, terminal where it ends. So we can name this vector using two different ways. We can call it vector AB, because A is where it starts, B is where it ends. Or you can just call it vector V, because this is labeled as V. The arrow on top just has, so when you draw a vector, it's not a whole arrow. It's just the arrow on the top. Because what would it be if it were a whole arrow like that? Just leave it there. Not a line. This would be a... Oh, this goes way back. What's one that... Ray. Yes, it's a ray. Okay? So a vector looks like this. This is a vector, whereas this would be a ray. So a vector conveys speed and direction. So again, the idea of a vector is that it's keeping track of something that's moving from one place to another. All right? So could we call this vector BA? No, because A has to be the initial point, so that means it has to be the first letter in our vector, the way that we're naming it. Okay? So either way, those are ways you can name it, but you could not call it vector BA. All right, so we can also name a vector using component form, and that's essentially just written like a coordinate. X is the horizontal change, and Y is the vertical change. So the component form of CD, why do you think it's called component form? Or what does component mean? Composed of it. It's like if I set a part of it, right? So components are basically the parts that make it up. So the component form of a vector is broken into 2 and 3 because you move over 2 and then you move up 3. So component form essentially looks exactly like a what? A coordinate or an ordered pair. Okay? X is how far you're moving horizontally. Y is how far you're moving up. So the component form of a vector is just over and then up. Go ahead.
Like what you're doing in a slope?
Exactly, except a slope is written as a ratio with Y on top. This is written as an ordered pair with X first then Y. So yes.
So we can find the slope and just write it as an ordered pair?
Yes, except make sure the X goes first. So you're counting over. It's like the opposite of what you do for slope, because slope you count rise over run. Component form of a vector is like run then rise. All right, so think of it like you're just figuring out what this ordered pair is as long as that started at 0. All right, so then what would be the component form of vector EF? Again, if it's vector EF, that means which one is our initial point? E. So it starts here and then it goes here. So to find the component form, it would be 4, -3. All right, because you're going over horizontally, 4, and then you're going down 1, 2, 3. Okay, so again, it's like slope, but as an ordered pair and written the other way. All right, so this would be the component form of EF.
That's what you do?
Yep, that's component form. I think vectors are simple, but... No, it's not going to. It's like going to put together a bunch of stuff that we've done, but.
How come we didn't do it where the F is going like this and then like that?
Wait, say that again.
You know, instead of going.
Oh, like instead of going this way? Because this is the terminal point, so you have to go from the initial point to the terminal point. All right, good question. All right, so if it had been vector FE, then you would have done that. Okay. How could we find the component form of vector PQ?
X2 minus X.
Yeah, basically the slope formula, except you're going to do x first and then y, right? Or you could plot it and count it. I'm lazy. I don't want to do that. That's a lot of work. So instead, we're going to do x2 minus x1, comma, y2 minus y1. So again, where did Bianca get that from? That's basically the slope formula, except that in component form, we write it as an ordered pair with the x's then the y's. So what's my x2? 4 minus 7 and 3 minus negative 5. Okay, so what's 4 minus 7? Negative 3, and 3 minus negative 5? 8. Good. So that means I'm going over 3, but which way? To the left, and then I'm going up 8. Okay, so I'm moving from 7 to 4 over 3 that way, and then I'm moving up from negative 5 up to 3, so that's up 8. All right, so again, exactly the same as the slope formula, but component form is x, then y, and it's written as an ordered pair. So that would be the component form of this vector. All right, so that's just component form. That's how we name vectors. The direction of a vector is the angle a vector makes with a horizontal line. So take a look at this. The direction of vector AB is 60 degrees because here's our horizontal line, and this angle measures 60 degrees. So the direction of the vector is 60 degrees. The direction is just the measure of this angle, and it's measured counterclockwise, which means like if this were our clock, we're going backwards from the horizontal axis. All right, counterclockwise from the horizontal axis. So how would you do this one? How would we do this one down here? Where would the direction of this vector be? So in this way, this time it'd be clockwise. How come? Because it's going down here. So I'm measuring from the horizontal axis. This is the angle I want, right? So then how would I find that? Yeah, so you make a triangle from here to here. How far is this one? And how far is this one? Okay, so if I have a triangle, and I have this is 4, and this is 2, and I'm looking for this, how would I do that?
Oh, that's
Opposite,
over
adjacent, and I'm looking for an angle, so what am I going to have to do? 1? -1 of which measure uses opposite and adjacent? Tangent. So I'm going to do tan -1 of opposite, which is 2, and adjacent, which is 4. So tan -1 of opposite over adjacent. So on your calculators, remember tan, to get tan -1, you just do second tan. And it's an angle, so 26.57 degrees. So this would be 26.57 degrees. All right? And again, this is why we do vectors now, because until you knew the trig ratios, you wouldn't be able to find that. Okay? So you're always going from a horizontal axis. So you're either going to go, if it were up this way, you're either going to go this angle or this angle. You're always going to use tan, because you only know this one and this one. You don't know the hypotenuse. Okay, so you're always going to use tangent with these. And if you're looking for an angle measure, it'd be tan -1. Okay, so let's try this one. A wind velocity is given by vector 2, 5. So I want to draw that on the coordinate plane, and then I want to find the direction. So how would I draw that? Yeah, where is 2, 5? On the right side, and then up how many? 1, 2, 3, 4, 5. So here's my terminal point. Where do you think my initial point is? 0, 0. All right, so here's my initial point. Because you don't have one, so you assume that it's 0, 0. Okay? And I'm looking for the direction of it. So I would have to make this into a what? Make this into a triangle where the base is how much? And the height is? Okay, so now I have this triangle. And I know this is 2 and this is 5. And I need the direction of the vector, so what angle is that? I'm looking for this one right here, right? Because I'm measuring from the horizontal up. So I need this angle. So again, it's going to be what? Tan -1 of opposite. What's opposite?
5.
Over 2. Good.
Oh, so you do from the horizontal, like that's what.
Yep. You've got to measure from here up. $21.80. Yeah, that doesn't sound right. Did you do tan -1? Oh, okay. So it's what? 68.2. So then the direction of this vector would be 68.2 degrees. All right, make sure you do opposite. So it's got to be opposite over adjacent. Okay, so go try these. No, don't try them. Do them. Go do these 5. You might not need. No, go ahead. Do all 5. Okay, so the magnitude of a vector, so the direction is the angle measure. The magnitude of a vector is how long it is. All right, so essentially how long it is from the initial point to the terminal point. So if you're drawing this vector 4, -2 on a coordinate plane, to find its magnitude to the nearest tenth, you're looking for how long it is from here to here. So if we are on a coordinate plane and we're trying to figure out how long something is, what do? The distance formula. All right, so the magnitude of a vector, to figure out how long it is, you just use the distance formula. And what is the distance formula again? X minus x squared plus y minus y squared. And essentially, most of these are starting at 0, 0. So you don't even really need to do the minus because it's just going to be 4 minus 0 squared plus 2 minus 0 squared. What's 4 minus 0?
4.
Squared. And what's 2 minus 0? 2. I'm sorry, hang on. -2 minus 0? -2 minus 0 is -2 squared is 4. All right, not -4. Negative squared is positive. So then that ends up giving you what? Square root of 20. And you can leave it like that, or you can simplify the radical, and it would be 2 root 5. Or you could write it as a decimal, and it would be somewhere between 4 and 5. 4.47. All right, so magnitude is just the length. So to find the length of any vector, you just calculate the distance from the initial point to the terminal point, and we use 0, 0 as the initial point unless they tell us otherwise. Okay, so go do these 2 at your boards, and then you're done at your board. So when you finish these 2, you can put your socks and markers up. Find the magnitude. Okay, so then the last thing with vectors, so far we've talked about component form, direction, magnitude, and then the last little piece with vectors is if they're parallel or if they're equal. So an equal vector means that those vectors have the same magnitude, which would be the same length, and they're going in the same direction. So vector u and v are equal vectors because they're going in the same direction and they are exactly the same distance. Parallel vectors, they are vectors with the same direction or opposite direction, so direction doesn't matter, but they do not need the same magnitude. However, since they're parallel, that means they're doing what? They're never going to what? Touch. So parallel means that they would have that same direction or exactly the opposite, but they can't just go like one, like this would not be a parallel vector because it's not going, it would ultimately hit that one, okay? So parallel vectors mean they're exactly the same direction or opposite. They don't need the same magnitude. Equal vectors mean that they're same direction and same magnitude. Are these also parallel vectors? Yes, those are also parallel vectors. So parallel vectors can also be equal, but they don't necessarily have to be. Okay, so on this, find me a set of parallel vectors. What would be a set of parallel vectors? CD and EF would be parallel. AB and GH are also parallel. And then what's a set of equal vectors? AB and GH, which are not going to be, I'm sorry, CD and EF are not equal. Why not? Yeah, EF is longer. Okay, so the magnitude of EF is bigger than the magnitude of CD. Okay, yeah.
Can we assume with that?
Like rather than finding, yes, because you could just count it to check that. So you could say like up 1 over 3, up 1 over 3. So yes, I'll let you, yeah, you can assume on that one. Okay, all right, so you're doing all of these because you have about 15 minutes left. Keep in mind number 2 is finding the magnitude, so that's where you'd use the distance formula. Number 3, you're finding the direction of the vector, so that's where you're using inverse tangent, okay? And then number 1, A and B, this one might be hard to see, so if you need to come up, you can. And this says -1, +1, 6, 2.